Okay, well, welcome everybody. It looks like, oh, all right, we're up to 77. Good crowd. This week will hopefully be kind of a crash course in how to work with Data Preview 0 and the tools that we provide for you to work with the data. So today we're going to focus on some very basics of accessing catalogs and working with those. And then in future days, we'll get to images, more complicated things after that. Much, or some, I should say some of the time will be spent in breakout sessions where it's really up to you, the students, to decide what you want to focus on during that time. So keep in mind, if ideas for like explorations you might want to do, and you can. The hope is that you'll form into small groups and learn together and from each other. So we'll come to that at the end of each day. We'll have breakout sessions. Today we'll probably mostly just introduce ourselves, but if that goes quickly, we can start breakouts right away. So to proceed, first I wanted to introduce you to the organizing committee for this virtual summer school, which includes 5 members of the Rubin community science team. You'll see us a lot because we are in charge of organizing the Data Preview 0. So it includes me, Gloria, Melissa, Ryan, and Douglas. All except Melissa all will be around today, it looks like. And then we have 4 Data Preview 0 delegates who are also on the organizing committee. That's Louise, Nandini, Vincenzo, and Fabio. I know Louise couldn't make it this week, but I think I saw the other 3 here. So reach out to any of us with any questions you might have at any time. And also presenting this week, 2 other members of the Rubin community science team. You'll hear from Tina in just a little bit, and from Greg also a couple of times this week. Okay, so I shared these slides in the general channel on in the Slack space, so you can access these links there. And while I'm thinking of it, I should mention that you should use the Slack space to communicate as much as you like. Feel free to, if you form a group doing some exploration together, feel free to create a channel to have your conversations in, but you can also use, we've created a separate Slack channel for each session each day. So add questions and discussion into those channels. You can use the general channel for any discussions, really. So Slack can be really a really helpful way to communicate in real time here. Of course, you're free to use the Zoom chat as well.
Jeff?
Yeah.
Can you put a link to these slides in the chat? Or can somebody?
I would have to.
One of us can do it. If you tell me where it is, I can.
Yeah, I would have to find it. It's in the DP0.2 folder. But,
oh, is it? Okay.
Yeah.
I'll look for it. But if anybody else can find it faster than me, go ahead and link them. Okay, yeah. Sorry, that's all I needed.
No problem. Yeah, so just a few links that are mentioned here. One, if you haven't, we're not going to talk to you during the summer school. We're going to dive right into how to use the tools and access the data. So if you want to know more about Rubin, Observatory, and Data Preview 0, you can see some of that in the short YouTube video that is linked here from the kickoff sessions that we had back when we first started Data Preview 0. You can also go and chat with people at the community forum. I urge you to use that as much as you wish. It is a platform for you to communicate with others. Of course, the link to the science platform you will need if you want to follow along with the tutorials, and the link to the Data Preview 0 website is here. as well as the GitHub repository, which actually I'll just click on this and take you there, just to show you that all of the tutorial notebooks live in this repository. And you can see that there is a nice description of each of them, telling you something about what sort of skills you'll learn from those tutorials. And you can also see further down much more detailed information about the skills and the tools that you'll be exercising in each of these tutorials. So, so do check that out. And another thing I wanted to highlight here is we also have delegate contribution notebooks. So these are from Data Preview 0 delegates who have done some investigation and have made it into a notebook that in many cases they have presented at a delegate assembly. And those are available here for you to go through at your leisure and to learn from. So this is in the delegate contributions DP0.2 folder. And so you can see there's a variety of things from exploring, you know, how background subtraction is done in the pipelines to the difference image analysis and various other notebooks. So these are also a resource for you to learn from. So I just wanted to point that out. And finally, we have a couple of links to more information about the survey that makes up the DP0 dataset, which is the DESC DC2, that stands for Data Challenge 2, simulated dataset. Okay, so getting on to the agenda for today, introduction announcements you've seen. Then we're going to go through an introduction notebook. It's simply called Introduction to DP0.2, which just gives you some very basics about how to interact with notebooks and how to access data products. Oops, sorry, it says session B there. After which, Tina will show you the portal aspect, because you can also access data via the portal, not just via Jupyter Notebooks. We'll have a brief break, and then Fabio is going to teach us how to do queries with the TAP service, which is the main means of access to catalog data products. And then finally, we'll wrap up with getting to know each other a little bit, and then hopefully that will inspire you to seek out like-minded folks to work together with this week. Before we go on, were there any questions or issues that people were having that you wanted to bring up?
It looks like in chat, some people are having some issues joining the Slack channel. Is that correct?
Joining Slack.
Yeah, I think mine is fine, but
Interesting.
Anyway.
Oh, yeah, looks like, okay.
Yeah.
Looks like you guys are trying to sort it. That's
Right, yeah.
That's weird. Okay, and I see that.
Yeah, so I'm working on it with Bob.
Sorry about that, Bob. I don't know what's going on. Okay. Oh, I didn't. Sorry, I should just start this from the way you enter the science platform. You're always going to go to this website, data.lsst.cloud, and you'll see the entry point here to the portal, to the notebook aspect, or that you can programmatically access data via the API. But we're going to talk to you mostly about the portal and the notebook. So this is what you would click to open the notebook aspect. I already have it open, so I'm going to go here. So for you to follow along, if you're logged in your home directory, you should see a folder called Notebooks. Within that folder, it has this, if I zoom this out, there we are, has this tutorial notebooks folder inside of it. And now you can see all of those tutorial notebooks that I showed you on the GitHub site appear here. If you want to experiment within these and change them, we recommend that you copy it to a different folder and then do your work there, because this folder is read-only and it's automatically updated whenever we make changes to the tutorials. So we recommend that you copy the notebook to a different directory and work from that, so that you can save any changes you make in the new directory that you create. So I made a directory here that is for the virtual summer school 2023. Here we are, and you can see we have notebook 1. So to launch it, I just double click it. And then you can close this sidebar that shows your file browser. Okay, so how do I kind of full screen this? There we go. How's the size look? Should I zoom in a little? Or is the font readable?
It's good for me.
It's kind of small, but it's okay.
Let's see if it makes it look crazy if I zoom in a little. Because we don't want kind of small. A little better? Okay, so I'm going to go through this quickly. This introduces a bunch of topics, but we're going to go into all of them in more detail later. So I'm going to go through it really, really quickly. Apologies for that, but you can work through it in more detail on your own time later. So this is really just to introduce basic things. For example, if you've never used a Jupyter notebook, we will briefly show you how to do that. This is a Jupyter notebook. So there are 3 types of cells. You can see that we've used markdown cells to format all of the text here. That's known as markdown. There are raw cells, which really just don't do anything. And there are code cells where you type code, in this case Python code, because this is linked to a Python backend. So so you'll type in these cells. So this one is a code cell. So note that when you put the hashtag at the beginning, that makes these lines into comment lines. So they are not code, but this is a basic Python statement that hopefully will print hello world. The thing to remember is if I hit enter here, it just creates a carriage return in the cell. You need to either click the little run button at the top, or much easier, hold shift and then hit enter. And when you do that, shift enter executes that cell. And so that's a code cell. This one is a markdown cell. So if I double click on this, now you can see the markdown that was behind that cell. So when I hold shift and hit enter again, then you see it executes it and renders it as markdown. And this is a raw cell that does nothing when you click it. So just remember shift enter, and I think you're pretty good here. There are a bunch of notes here about how to, if you get some process that you accidentally just queried, for 100 million objects when you really only wanted 100, and it's going to take forever, and you want to stop it. It has some notes here about how to do that. It also has notes about just execute the entire notebook. You can use some of the menus at the top. You can go to the kernel. You can restart the kernel and run all cells. That will just restart everything, the Python kernel, and then it will execute the whole notebook. You can also go to the run menu and say, run all cells, or run all, the selected cell and everything below it, things like that. I mentioned the kernel. The kernel is just a Python backend that you're using. And so when you restart the kernel, it clears all your variables and everything. And so it's sort of like a clean slate. If you want to view the table of contents of what's in this notebook, you can click this little hamburger looking menu over here, and you have your table of contents. And another thing that will come up frequently is you remember when you logged in, you needed to choose which version of the pipeline you're going to use. That if you forget which one you signed in with, you can see it down at the bottom. It says here weekly 2023_21 is the one that we're using. And to change that, you have to log all the way out and then log back in to change the version. Commenting out these two lines also shows you another way to retrieve what version you're using. Okay, so then we get to Python. You're going to use a bunch of packages that you import. This highlights some standard ones. NumPy is basically all the computing with numerical arrays. Lots of tools for basic computations. Matplotlib is for plotting. Pandas is a more I guess scalable way of working with tabular data. AstroPy is a suite of astronomy tools, so you'll see that quite a bit. And then anything that you see where we import LSST dot something is tools from the LSST science pipelines. And you can see there are links for more information about all of these in the notebook. And so here you see we just import those packages that I mentioned, NumPy, Matplotlib, and you can see that we can import it as, we can import matplotlib.pyplot as PLT. And so then when we want to use it, to call it, we don't have to type this longer path, we can just say PLT dot blah. And then here you see pandas and some LSST packages that we're going to use. And so again, Shift Enter to execute that, and it imports all of those packages. So now they're available for us to use. We'll skip by this. If you want to know what version, you can do this. If you uncomment this cell, this shows you a really useful thing that you're going to use a lot, or you may want to use a lot. Okay, if I type one of these packages that we imported, for example, NumPy, if I type NumPy dot and then I hit tab, this shows you all of the methods that are available from that package. And so you can see like absolute value. I don't know. Oops, that didn't work. What's another good example? You can concatenate some arrays. You can take the cosine of some angle. So this is an easy way to see like what are all the methods that are associated with this object. If you execute this cell with just NumPy dot, it's going to say that's an error. That's not proper because we didn't actually call one of the functions. The other way you can see lots more information about what's available in this package is just to say help, and then in parentheses the NumPy or the name of the package. And so this then tells you all about the package and some examples, some all of the utilities that are available and all of its contents. This scrolls forever, by the way. So we don't want to have to scroll past all that right now, but you can later if you like. So we're going to uncomment it, or we're going to comment it again. And if we execute that again, now it goes away because everything's commented out. Okay, so that was a really basic Python in a notebook intro. Sorry, we can't go any further than that right now. But now we're going to get to how do you, what do you need to do to access the catalog data, the DP0 catalog data? We use what's called TAP, the Table Access Protocol. It's a standard service that is used throughout astronomy. And it uses a language that's kind of similar to SQL, if you're familiar with SQL database queries. All of our catalog data products live in databases that we use this tap service to access. And so the first thing you have to do is just initialize it. So you just do this thing where you say, okay, the service is get tap service, and then you put tap in the parentheses. So that has initialized the service. So now we can execute some queries using that service. Okay, there's lots of info here, which, sorry, we don't have time to go through, but we will just show you some examples of using some basic tap queries to see what's in the tables. And note that we also have what's known as a schema browser. If you want to know that, we're going to show you here how to see what's in the tables from the notebook, but you can also click on this and it'll take you to the schema browser where you can see the columns that are available in each table. Okay, so for this one, we're going to uncomment all of these. And so what you see here is we're defining the query just as a string here. That's in the double quotes, where we just say select the description and the table name from the tap schema's list of tables. And then in the next line, we execute that. So we say service.search and then give it that query. And then just to make it look nicer, we convert it to a pandas data frame so it'll display more nicely on the screen. So let's see what happens there. Okay, so now you see a list of 22 tables, 23 actually. So these that have DP0.2 in them are what you're going to want to use. You can see the old data preview 0.1 tables are still there, but we want data preview 0.2. You see object table, for example, source table, forced source, difference image objects, various others. And you'll learn a lot more about what each of these tables means, what it contains as we go on. So the second thing we're going to do is figure out, okay, within one of those tables, what are the columns that exist. And so in this case, we just say, in our query, we say select star, which just means everything from that tap schema again, dot columns. And then we say where, you're going to see this a lot. It's usually select something where blah, and this is the condition where, okay, where the table is the object table. And then we execute the search and you see that it shows you the fields that are available there. And now we go one layer. We can go one layer deeper, where now we want to figure out from that, we want to figure out what columns are in this table. So now we're going to go a level deeper and look for column name. In this case, we retrieved them all. And then we just printed the length of the table. There are 991 of them. If you want to see them, you can uncomment this next cell, and you can see this tells you the column name. It also gives you a brief description about what's in each column. I'm going to comment that out again and go back. But then, of course, once you retrieve that, if you want only things that have, for example, a flux measurement in them, you could say, in this case, we want the C model flux. We can say this is just a loop that's going through and picking out only those with C model flux. And then you can see that you get still a bunch of columns, but it's not 991. So that's a way to sort of search within those columns that are returned. And then once you decide, okay, I know which columns I want to retrieve, I want to get some data. Now we're going to go and grab some data after a couple of notes. First note, if you provide constraints in right ascension and declination, that will yield a much faster query. Because the data in the database are actually sharded spatially based on RA and DEC, it works much more efficiently if you provide an RA DEC constraint. And you'll see a couple of tricks here to retrieve just a couple or a small number of rows. And a recommended constraint, this detect is primary, flag is your friend. It gets rid of like duplicate detections and things in overlapping regions between two adjacent images and things like that. So do read these in more detail if you want to know. And I'll also note that all of the things in the database are stored in flux. And so if you want to convert to magnitude, this gives you some information about how to convert to AB magnitudes. You can retrieve the fluxes and then do the calculation yourself here. Or there's also a method that you can include in your TAP query that will actually do the conversion for you. So that's this this SQL nanojansky to AB mag function can return the magnitudes for you. So you'll see that a lot. Okay, so we're going to just pick 10 objects around a certain position. So we're going to just define these center coordinates. This is a RA 62, DEC minus 37 degrees. And then just to check whether your query is doing what you'd like it to do, you can just do the select top 10 and it'll only give you 10 results. And we're going to learn more about how these queries are constructed later. So I won't go through this in detail, but this is just specifying the columns that you want from the table that you want, where things are within 0.01 degrees of the coordinates that we provided previously. And then you execute the query and we'll see what that table looks like. We'll do that conversion from flux to magnitude. And here you are. You have your data, you have magnitudes, you have fluxes, you have the RA and DEC and the flag that we selected on. Okay, what if you want 10,000 objects instead? Let's search. This is now, notice it uses a 1 degree radius. And you can see we're providing some other constraints too, where we want things that are not extended. So we say where this extendedness flag is 0 for false, not extended. And now we're going to select the top 10,000. Okay, and you can see that just took a couple of seconds. And here's what happens when you display that. It doesn't show 10,000 results unfurling endlessly in your screen. It actually truncates it for display. So you can see what the contents are at least, but it doesn't display everything. We're going to convert it to a pandas data frame just for ease of use later. There are some cells here which we won't look through right now, but this just shows you how to work with some of the pieces of that pandas data frame. For example, if you want to see the number of columns or what the columns are named, if you want to see the values in a certain column. But first thing I always want to do when I select a bunch of stars from a catalog is make a color magnitude diagram. Let's do that. You were going to use that matplotlib package that we imported before. So that's this plt.plot. And note, this is that pandas data frame where we say data, and then we select the column, our calibrated magnitude dot values. And then so we're doing R minus I on the x-axis and G magnitude on the y-axis. And then this just sets some of the axis properties. And if we execute that, you see a kind of weird color magnitude diagram. I'm sure it generates a bunch of questions in your mind immediately, like why are there vertical stripes? That is beyond the scope of this notebook for now, but think about it or ask about it later, and many of us are happy to explain. Finally, I just want to show you one last thing, and then we can get to Tina showing you how the portal works. The last basic thing I want to show you is how you would access and display an image in the notebook. The images that you're going to most commonly work with are either the CalExp, which is, I believe, calibrated exposure. So that's a single image from one visit. Or the deep coad, which is a stacked image of many visits to create a deeper co-added image. When you're working with coads, they are stored in things called tracts and patches. Basically, a patch is a 4K by 4K pixel image, because it's basically, that's about as big as your computer can handle to work with in memory. Whereas a tract is made up of a bunch of patches. And a tract is basically, the size of it is determined by how big an area can we create that shares the same WCS solution. So anyway, patches are just subsets of tracts. So you'll often need to know the tract or patch to find the image that you want. And then you're going to hear a lot more about the butler later, so I won't get into it, because probably you see this create an instance of the butler and go, what the heck's a butler? We'll get into it more, but it's basically the tool that we create in the LSST science pipelines so that you can retrieve data without having to know the location of a file or the format of that file or anything. This sort of just abstracts away all of that. So if you just know the tract and patch number, for example, that you want to retrieve, which you can easily get from the RA and DEC position you're looking to retrieve, then you just say, hey, Butler, I want this deep coad image from this tract and patch. And so this just instantiates a butler for pointing to the data preview 0.2 collection. And we have a whole tutorial on this, I believe tomorrow or the next day, possibly the next day. Okay, so here we're going to just define an RA and DEC position, and then we have to create this sphere point object so the butler or the science pipelines know how to interpret that position as a position. We create that position, and then we go and, as I was saying before, you can, from that position, find the tract and patch that correspond to that position. So that's what we're doing here. And so now we have a tract number 4431 and patch 17. And so then we just create what's known as a data ID. And it has, we tell it we want the I band image, we want the tract and the patch that we located. And then we just say, okay, my coad, we say butler.get the deep coad image, and we give it that data ID. And that should give us an image at the position that we specified. So you see it takes a couple of seconds, and now we get that image, and we're going to display it. You'll hear a lot more about image display this week, especially tomorrow. So we're just going to use a tool, again, an LSAT science pipelines tool called AFW display. We're going to use that to display the image, and we all ooh and ah at the beautiful image. Ooh, check out that galaxy cluster. And that's where we're going to stop. And we're going to learn a lot more about all of these tools as the week goes on. That's all for this intro. If there are any questions, we can do a couple of questions real quick before we switch over to Tina showing us how the portal works. I see lots of chatter going by in the meeting chat. I hope everybody's. Yeah, I see people are having some issues getting things started. Any questions about what you've seen in this tutorial? Ah, yes, I see the question about using tracks and patches. So for the you always need, when you're using the butler to access data, you always need a data ID. For COAD images, for the stacked images, you will always need a tracked and a patch. For the single visit images, the CalX images, those have dimensions of the visit number, because each visit is assigned a unique number. So for those, you'll need other dimensions that are a visit and a detector, because there are many detectors. And actually, I think, is that all you need? Visit, detector, sky map. We'll get into that a little bit more when we get to the butler tutorial, but yes, you'll always need to know those called dimensions. Yeah, and I see your follow-up too, that yeah, so using RADEC and the time won't work directly, but you can you have to do an extra step to get to the data ID of the particular image you're looking for. Okay, and the other, I think I saw another question just pop up. Oh, where'd it go? Okay, maybe not. Yes, okay, there we are. I see. Robert said, are there overlaps near the borders, or do edge issues occur? Yeah, for the because for COADs, the tracks and patches are, that's we've just artificially created that that system, and so it does have some overlaps at the edges, and that's one of the reasons that detect is primary flag that I used before. Then the catalogs for those two overlapping images might contain the same object, and so when you use that is primary flag, it will select what's basically deemed the primary or best detection for those. So there are some small overlaps between patches and actually between tracks. Oh, and I see some other things before we move on that are related to access to the RSP. If you just requested an account, I can approve those. I'm not sure, let's see who else we have here who has approval privileges. I don't know, I can't see if Andres is here, but I can approve those soon. So if you're waiting on that, you should see a message soon that you've been approved.
Hey, Jeff. Yeah, so Gloria has been contacting Andres about it. So yeah, we're working on getting people access.
Oh, awesome. Yeah, because I think it's Andres, me, and Melissa who have approval privileges on that.
Yep. So we did have a question on the Slack channel by John Loveday, who asks, is the butler only used for accessing image data? In other words, use TAP for catalog data. So I think we might get to that later, but maybe if there's a short answer. I see Vincenzo has also responded to it too.
Yeah, it's a good question. You can access catalog data from the butler or the TAP service. We recommend the TAP service for catalog data, but you can, for example, if you just want to retrieve a particular patch, you can do that directly from the butler if you want. I see Douglas's hand up.
Oh yeah, sorry. Noting the large number of questions on the chat, I was just wondering, are we encouraging people to use the raise hand feature to ask questions either at the beginning or the end, or during or the end of each presentation?
Yeah, thanks for mentioning that. I forgot to mention it before, but yeah, you're welcome to raise your hand at any time if you have any questions, or of course use the chat. Either is fine.
Thanks.
I see Marina's hand.
Hi. Yeah, I was wondering about the image, how to retrieve images. So how does it work when we have an image that is spanning a different tract, for instance?
It's an interesting question because the tracks and patches then are made up of, visits that may have been all over, and then that's just imposing a sky map, essentially a grid onto things. So if you say like, okay, I know this image was here and it might have been added into two different tracks, you can retrieve that by like something like what we just looked for, where in the example we just picked one position and said give me the tract and patch that overlap that, but you could also say give me a 1 degree radius and give me all the tracks and patches that overlap that. And so you can retrieve a list that way and then get them from the butler.
But then you will retrieve individual images and you would need to stack them yourself? Or?
If you wanted to make a mosaic image of those, then you would need to put them together yourself after the fact, after you retrieve them.
Thanks.
And that's partly because once you get, like, you can't, in the science platform, you can't display an image of an entire tract because it's just too big to be held in memory and displayed. And so you need to retrieve things as patches. You could probably mosaic a few patches together and do it, but to do a huge area, it's just too many pixels. All right, I think we should move on to a portal tutorial with Tina. And of course, you all are welcome to ask questions either in the meeting chat or in the Slack. And I see lots of people have been responding, which is great. So for now, let's move on to a portal tutorial.
Yeah, very good. I'd like to shout out to the Tucson group because they are working hard. I can tell in the chat. So good job. I just put in a link in the chat for the DP0.2 documentation. I'm going to share my screen real quick. So the link that I just sent you will take you to the documentation. This is for all our delegates. So we have resources for DP0 delegates. We have data product descriptions, data access and analysis tool descriptions. And then if we go down to tutorials, we can access the portal tutorials, and I'm going to work on a portal tutorial right now. It's kind of interesting. I'm going to show you almost the same thing that Jeff just showed you in the last notebook tutorial. So if we click on portal tutorials, it will take us to our tutorial page where we have portal tutorials. That's kind of hard to say. And then we are going to work through the bright stars color magnitude diagram portal. So you click on that, which will give you the instructions that you need here. There's some things that you will potentially need to cut and paste from here because it makes your life a lot easier. And I'm going to switch between this and the RSP aspect. So I'm going to go to, the portal aspect. So if I go here, you were just in the Jupyter Notebook part of the RSP. So if you open another tab, oops, let me try it this way. If we open another, I hope I don't crash my computer because that would be bad. Data.lsst.cloud, open another tab, you will still be logged in. And now you can click on portal, which we will do here. I still hope I don't blow up my computer. This is the portal tutorial that we have. This is the portal aspect that we have where you can interface with the portal and get information from here. So I'm going to show you here where we are. I'm going to switch back and forth. I hope that doesn't mess anybody up, but we just logged into the portal aspect. Is anybody having trouble with that so far? Should just pause. You can also just speak up. Okay. I'm going to move this off to the side for a second. All right, everybody seems to be fine. So if you'll notice here, we have a window where we're performing tap searches. There are some buttons that you have up here. You can log out. You can, over here, this tap services and view, you can click on show and it shows you the selected tap service, but we don't really need that at the moment, so we'll just hide it. We also have our LSST DP0.2 tables. We will be looking at the default. What we have is the DC2 catalogs, and that's the table collection or the schema. And then we have our table, which is catalogs.object table. So we're going to be doing those. That is, we can also, this is UI assisted, or you can edit ADQL. I'm going to click on this real quick, which will bring you to an ADQL. If you just already know what you're going to type in, you could do that here. Just to let you know, there's also, once you get this set up, you can populate and edit the ADQL, which is kind of a cool feature. All right, so we are looking at those. Yes, Douglas.
Oh, I was wondering if you could maybe increase the font size a little bit.
Ooh, okay, let me try.
Okay.
I was at 90%.
Great.
Is that better?
That's better. Thank you.
Awesome. Thank you. All right, so next, we are going to, I'm at 1.4 where we're going to enter constraints. Move this out of the way. Everybody still doing all right? All right, so here we're entering constraints. We're going to leave the spatial selected. We're going to leave cone selected. And now our coordinates of the object name, we're going to search in the same spot that Jeff just demonstrated in the notebook, 62, -37. So that's our RA and DEC. We would like to search a radius of 1 degree. And the best way to do this is to do degrees first and then change your size of your radius search. If you do it the other way, you have to go through an extra step. It's really annoying. But so if you were to put in like 0.5 degrees and then go change it to degrees, you have to go back in and fix it again, which is annoying. Our position columns are still going to be our RA and DEC. We're not going to do the temporal stuff right now. So this is the first section that we do for constraints. We just did 1.4 in the tutorial. Does anybody have any questions, or everybody is caught up for that? Okay. Next, we're moving on to 1.5. We're moving over into this big table, and I'm going to scroll down real quick. It's a very large table. This is all of the information that we're going to get from this catalog. What you will do is you will select specific items. So we're going to select the RA and DEC. We are also going to select detect is primary, which Jeff mentioned earlier. So this is going to be basically objects that don't really have any children associated with them. And this list is in alphabetical order. So we are going to also select G Calib Flux here. So we're going to put a check mark there. And G extendedness. We're going to get those. Next, we're going to do that for I and R as well. So we're going to scroll down to get to I and select I Calib Flux and I extendedness. And then R is also what we're going to do, if I can get there. Okay, excuse me, R Calib Flux and R extendedness. Okay, so once we have them all selected, you go up here and you click on the filter on selected rows. You click on the little filter, and that magically brings you only those items that you selected. Everybody doing okay so far? All right. So next we are going to put our constraints in here. So for detect is primary, we would like to put in equals 1. For the nanojanskis, for the G Calib flux, we would like it to be greater than 360. And we're going to convert that to a magnitude in just a second. Extendedness, we want equals 0. So this will limit the object's return to those with no children. And it's going to be brighter than the 25th magnitude in the R, G, R, and I filters. Which appear to be point-like, but are not necessarily stellar. So that's actually in the tutorial. So for I Calib flux, same thing, greater than 360. Extendedness equals 0. R Calib flux is greater than 360. And extendedness is again 0. All right, and this is kind of cool. After we get all this in, we can deselect the extendedness and detect as primary, because what that does, it sets the constraints, but when you actually submit the query, you won't get that in your table. And so it's just data that you don't really need in your table. Okay, just to show you some other things here, if you're in this process and you messed it up, you can remove the filter and reset the columns. You can also populate and edit the ADQL at this point, which I'm not going to click that button. Row limit, change the row limit to 10,000 rather than 50,000, just so we don't get as much. And then we will hit search. When you hit search, you will get this search wheel. And finally, you'll get a try view, which has the data table down here. It has a graph with the RA index, and then you'll have this image. And if I zoom out, I have a wheel. You could also zoom out using this, but I have a wheel on my mouse. And if you'll notice, they're kind of the same weird cutout shape. And that is because within this 1 degree radius, we have more than 10,000 sources. And so this is just the 10,000 sources that I have, my computer has selected. Your image might look a little bit different. So if I click on one of these points, you'll notice that there'll be a point selected over here, and then also the table, the row corresponding to that object will also be selected. All right, so now we're going to quickly make a, yes, sir? Yes, Doug.
Yeah, sorry. I in case anyone else ran into it, I actually put like 360 with the decimal point. That seems to result in an error. So don't use a decimal point.
Okay, thank you for the tip. So you can also change your views here with tables or images, but we're going to stay in the try view for a second. Okay. Next, I'm going to put some information into the chat again. So what you're going to do now is we're going to change this from basically the coordinates to a color magnitude diagram. So if you click on the chart options over here, the 2 gears, you're going to click on that and you will have a table that pops up. We're going to modify the trace. And I'm going to change my X and Y so that we can create this color magnitude diagram. So our X, I'm going to put something in the chat. You can try typing this if you wanted to, but it's not easy. So I've tried this many times and it messes up. So that function, that calculation right there is what Jeff showed you that we did before to change the fluxes into magnitudes. And we've actually done R minus I here. So that is what that is. If you'll notice in the chat window, it does have R Calib flux minus the I Calib flux. Then for Y, hold on, let me copy this one. For the Y value, we would like to use this equation, putting it in chat. So you copy, oops, didn't work, hold on. There we go. All right, so that is the equation that we're using for Y, and that is just the magnitude of G. Everybody have those? Okay, next, we're going to leave trace options alone, but if we go and click this little arrow for chart options, we have some things we can do here. We can label it. We're going to call this a color magnitude diagram. Our X label is going to be color R minus I. And then our Y diagram, or I'm sorry, our Y label is going to be magnitude G. And we're going to reverse the axis here so that our magnitudes are going the way we expect them to. Also, we would like to set the minimums. If I were to do this right now, I like the whole span of all the color ranges and the magnitude ranges would be there. So we're going to constrain this. The X minimum is going to be a negative 0.5. We're going to do a maximum of 2.0. So that's the color range we're going to have for this. And the Y values, 16.5 is our minimum, which is our brightest. And then 25.5 is going to be our limit. And then if you hit apply and then close, what you'll see is basically the same kind of image that Jeff showed in the last tutorial. If you go into the instructions for the portal tutorial, they give you a reason why this is quantized the way it is. So if you're curious about that, you don't have to figure it out yourself. There's a written description. Okay, but we would like to maybe see if we can use this information a little bit different. And so now I'm going to create a heat map. This is part 2. I think I'm on 2.4 if you're looking at the portal instructions. Does anybody have any questions yet? And is my pacing okay? Is everybody following along okay? Yeah. Okay, so now I'm going to click on the double gears again. And this time I am going to add a new chart. And instead of having a scatter chart, I'm going to use a heat map. The X and Y parameters are the labels that we have, and the numbers that we're going to graph are actually the same ones that we used before. So you can go into chat and copy those again. So our X value is going to be R minus I, the same thing there. And our Y value is going to be G magnitude. All right. Our color scale for this one, I'm going to try to select the gray sequence because I'm going to show you a trick in a second. The number of bins for X and Y, we're just going to select 100. And now our chart options, basically the same information as before, except we're going to call this a heat map. Our X label is still going to be color R minus I, oops, magnitude G. And we're going to reverse it. And to keep everything consistent, the same constraints on the minimum and maximum for X and Y. Okay, now we're going to hit OK. And then now we have a heat map. This is a grayscale heat map, so it's not as useful. I'm going to show you one trick real quick. So actually, let me expand this a little bit. No. That looked like a Minecraft thing, right? Or something. All right, so I'm going to click the double gears again. This time, I'm going to modify the trace. And I would like to use the yellow, orange, and red option. So I'm going to click on that. So I clicked on the double gears, modify trace, and the color scale. Now I'm going to choose a color scale that actually fits my needs better, and then hit close. And now we have a color magnitude diagram and a heat map diagram of the data that we selected over here. Is everyone able to do those? Because we're kind of out of time. I'm cutting into your break and I apologize for that. Within the tutorial, you can also do some really exciting things. You can do the same query with ADQL. And so that button at the bottom with the first selection, you can edit and populate the ADQL. And you could also, excitingly, transfer this over into a notebook and run it again in a notebook. But I will leave those exercises for the students to work on. And are there any questions? Okay, well, then Jeff, I will hand it back to you for the break.
Oh, hey, Tina. There was a quick question in the chat about whether or not you can export the tables to work on a notebook, but I think you also did just touch on that right at the end of your demo.
Oh, you can, yes, you can, hold on, I switched it off. You can transfer the code, the ADQL code. There is a way to save the tables, but Jeff, do you remember how to do that exactly? The tables, you can save the data from the tables, correct?
Yeah, you can. You can actually save it and then take the link and use the link to retrieve those data from within a notebook. Actually, I'm trying to think if that's in it. Is that in one of our tutorials? It's got to be. I think we'll come to that later.
Good question.
Yes, it is in my tutorial right after the break.
Yay, very good. Thank you.
Perfect. Okay, so we are due for a 10-minute break. So I see it's 4 minutes past the hour. So what if we just say we'll return at 15 past the hour? We'll take those 10 minutes and then we'll come back with a tutorial from Fabio, who's going to show you how to do more things with tap queries. And I should note that those of you who registered for accounts, I've approved all but one that I see. Yeah, so I'll be handling those as they come in as much as I can. All right, 10-minute break. See you all shortly. All right. Hope everyone appreciated the break. We are back for another tutorial session. This will be brought to you by Fabio, who's going to show you notebook number 2, tutorial notebook number 2, which shows you how to do query catalogs in more detail than what we saw earlier using the TAP service. So you all ready to go, Fabio?
Yes, I can go. Let me share the screen. Can you see my screen? Yes.
Yeah, looks good.
Okay. So let me start just starting from what Jeff said, that the TAP is a service to access the data. It's a web service, and it uses the SQL, basically the ADQL languages that supports different kind of query language, among those the SQL. So anything you can do in SQL, you can do also using the same way to query other databases using that languages, and just typing as I use it if you know how to use SQL. But to add something more to what Jeff showed you, the different tables you can access in the with the TAP are basically a relational database that you can query using a common column that is present in all the tables, and this allows you to do like a intersectional queries through the different tables. But I'm gonna show you how to do that in the later on in the notebook. So just to start, let's just import all the module. There in this notebook we will see also the bokeh module, that is a visualization package in Python that make it easy to produce interactive visualization. So let's just run this to cell to visualize better the pandas data frame that we are gonna see. And this is a function format, a way to program a function using Python. If you are not used to programming in Python, using this def keyword, you define a name for your function, and in the brackets you can define the variables of your function. After the common point, you can just write down all the operations that your function that you want your function do, and then exit your function with the return key. That is what you want your function to return after you call it. So we are gonna initialize. We're gonna get the instance of the TAP. The TAP is, as I said, is a web service. This means that it needs a URL to get reference to where the tables are, and instantiate. When you get the instance through the get TAP service, it does that automatically. However, TAP service can be also used by external software as Topcat, and typing this command service.base URL, you can access the URL that you want to give Tomcat service to access the same databases that you are going to access using the top from the RSP. But how we can access the tables that are stored in this web service? Running this query, we can see all the tables. We can access the most basic level of the schema for the databases, where you can see basically the names of the of where the data can access to, and description of each of the tables. For instance, the tables that we saw in the previous notebook were from the DP0.2 catalogs, and here we can see the description of all you are gonna find in the table in these tables. So we to get it, of course, we need to save the name of tables we want to dive into, because it will be easier for us instead of typing in the query later. So that's what this cell is going to do. It's just showing to you what is the schema that you were looking for. In this cell, we were looking for the DP0.2 tables, and so we searched for the DP0.2 in the name, and after we defined the for loop on all the schema names in the results. And here we can see all the tables that are stored in the DP0.2 schema, where the schema, just to be clear, is just a representation of where the data are stored. So that's why the schema is the let's say level 0 of the flow where you can find your data. Okay, just to add more in this on this topic. Of course, you can look for all the feature that you can query on the web pages for the data preview 0. But if you want to just access all the features that you can query, you can just try search for all the keys in the in the schema. Here, typing this query, running this query, you have this table that basically has the same functionality of the table before, but instead of having the names of the catalogs you can access to, has the names you can ask the tab query to search for. And as before, every table has the name of the features in that catalogs, and a description of what you can find in that specific table. For instance, in the first, just to describe better what this query is about, we are asking to select everything from the tables in the top schema, where the top schema, the schema name is DP0 DC2 catalogs, and we are ordering from the by the table index from the lower to the higher index. And the first index here, as you can see, is show the properties of the objects that are detected and measured in the deep cohort. Here, there is like a description of what are the different levels of the of accessing the catalogs. And as I was saying, the top schema is the specific schema describe the top service, where the schema is the way is where the data are stored in the database. But then we have the different tables that we can find in the database, and as we saw, the table collection that we can find in the top schema, and the results basically here. The end of that is just the end of the top service operation where you have your table out. I don't know if there is already some question on these, or everything is clear, or everything is basically very confused and and nobody has anything to say.
I haven't seen any yet, Fabio.
What, sorry?
I haven't seen any yet, so I think you're okay.
Okay.
Give it a second, see if anyone wants to raise hand.
Perfect. So I'm gonna continue. Of course, here we already know what kind of column we want to search. And this again can be done by searching the features on the web pages, or typing the select instead of specifying the names of the column in the first, let's say, in the order 0 of your search of your query, you can just type star and you will have everything, all the table with all the column, and then in the first order search, after you know what are the column that there are in the table, you can rerun the query with the column names that you want to search for. And in this query, we are searching in the top schema column, where the table name is the catalog, the DP0 catalog object. So we are searching this first table, where we will find the properties of the objects that are searched, that are detected and measured, so that we can see what are the features that we can find in the tables containing the sources with the description, the unit, and the data type. If we are not sure that a given column is in a column name of a table, we can search for that for that specific string in the results, instead of showing in this case, if your table has too much column to be read by eye, you can search the column name of that specific table. A good practice is to delete your table after you use it, because sometimes if the query if the query has a lot of sources, your memory can break down and the notebook will crash. So it's a good practice after you saved your results in some kind of format, delete your results. And as showed before, the search is faster if you have like a box, or in this way a circle where you want to look for your sources. And so you want to use Skycord to have the correct format of your array index. And as it was already said, that to avoid duplicates, you can put this constraint in your search. And this is a sort of a more complex query respect what was showed in the previous plot, where you are searching. You are in this if previously we used I'm pretty sure, sorry if I'm scrolling up and down, but I want to show you this. Okay, we didn't use here the maxrec variable that we used in the previous notebook. Here we define the maxrec value, can also be substituted by putting this select top keyword at the beginning of your query. If you put it at the beginning is a good practice, but you can put everywhere in the query. So we are searching for the top 5 rows. We are going to show the first 5 rows of the query, where the query is on the object ID, the array index, and the detect is primary, and all the others features of the table, where these features are from the catalog object, where we can all the features are from the catalog object, and in the where with the where keyword we apply the constraint of our search. And so with this how to say, with this format, we are just asking the query. We are creating a query considering the center as a center of our query, the array index, the array index, the array index column, considering them as a point, as a coordinate format. So we have the array index in ICRC format. As you this kind of format is the same of doing the SkyCourt frame ECRS using SkyCourt. The constraint is just a function that say constrain the search, constrain the search on all the coordinates that are in the circle, where the circle has the same frame as the point and is defined with this center and this radius equal to 1. So equal to 1 is not the of course is not related to the circle, but is related to the contains. So it's the output is in the circle or is not in the circle. 1 is in the circle. So we want to constrain the selection just on the point that are in the circle. And as said before, we are searching for not duplicates and for point-like sources, where the extendedness is a flag, is a Boolean flag, where 0 is point-like and 1 is extended sources. And just one thing more about this query that, as you can see, is kind of complicated, but is worth to acknowledge this function that does the conversion from flux to magnitude, as was done before manually in the notebook that you just saw. And so here we are asking to constrain the search on all the sources that have an R magnitude less than 18. So they are brighter. Sorry, they are fainter or brighter. No, they are brighter. Sorry, the confusion. I'm just a little bit nervous. First time I'm doing a lesson to someone, and we are ordering the and at the end, this is just a way to order the output of our query. So this is an assert that raise an error if this request does not hold. Oh, sorry, I forgot to run the max. Okay. So just as you can see, this is the result of our query. As you can see, what we show here is just the first 5 outputs of the search, and this is not in the Tupanda. Okay, this is a nicer way to see it. A different way to do the same search without the select top is to use the maxrec variable in the query. So the two queries are the same, and this function just acknowledges that it will be raise an error if the two tables were not the same, and we can also see that the object ID are basically the same as the number of the of our outputs. And then, to not stress the kernel, we deleted this kind of results. As I was saying, all the operation that we expect to do using SQL can be done also here. And the fact that the different tables has common columns allow us to join the results, the queries from different tables. So we can here the formalism used in this query is a bit different from the previous one. As you can see, we are not using the entire name of the table, but just an abbreviation that you define later on the select. So before you want to select, to define your selection, as you did before, and then you say the abbreviation I'm using is the forced source table, and I want to join this search with the search on a CCD visit, and here I'm using another abbreviation, and here after the join I have to define which one of the column from the different tables I want to query to do the cross query, let's say. So here this CCD visit ID, and here on object ID we can ask it for a double constraint on the tables. So basically, adding these four lines, we are referencing the common column that are in the forced source table and in the CCD table, so that at the end of the search we will have just one column for the CCD visit and one column for object ID that are referenced to the same object, and the rest of the query is almost the same. We are constraining this specific search just for the airband, and here you can see the result, the results where we have the forced sources ID from one table, and we have the CCD visit ID from the other table, and the text is primary from the forced source table, and etc. So we can run our analysis on the sources. Sorry. Just counting the number of objects we find by IDs. And here we can check the forced photometry on the sources. Any question? If not, I continue. Here, okay, there are different kind of queries that you can that you can run if you know, for instance, the ID, the object ID of a source, because maybe you are interested in one specific source and you want to retrieve all the photometry in the forced photometry and the photometry on the science image you are in, for this source you are interested in. You might have run the for instance the search on the portal, and then you wanted to work with this data for that specific source you found on the portal. You can use the information you retrieve for the object ID and constrain your query using the object ID. You can do all the different kind of query you can have in mind. Just be sure that the column you want to query are in the table you are querying, and then you can do everything you want, basically. So as I was saying, here we I think I'm running out of time, so I'm gonna just a little bit speed up. If we here another kind of query, very complex query, but if you now are understanding how the SQL formalism works, actually is not so complicated as it appears. It's just heavy to read, but once you figure out how to read it, it would be easy. So as you can define abbreviation or variable name for tables, you can do that also for the specific column names, as it states here in the second row. Here we are naming the column name cord array, just array, and cord underscore deck as deck, and we are querying all the features of the table we are interested in, and we are constraining the search on the magnitude. And here we just asked for the extendedness not to be null. So here we are searching for both stars and point light and extended sources. As you can see here, and here the detector is primary, is just assuring us that we are not there are not any double sources in the table. Here we define, so here just some data preparation to plot the data using the bokeh package. Bokeh package allow to easily plot a wide database, but he needs to have some references on what are the things that we want to plot. To do that, he asked for a dictionary where you state what are the the intro of your database, and then you define this column data source that basically is a data frame that it refers to produce all the objects in the object in the plot. So we are defining the target array index of our search and all the array index of the query of our query. And here we are just defining the color and the magnitudes that we are that we searched for. We searched for just for the magnitude, but basically we can find all kind of variables in the dictionary that we want to plot. So we can also map the objects to see if they are star or galaxy, because in our database we have 0 and 1, but in this way you can change the references, and where is 0 you will have a star, and where is 1 you can find no, all the way around. Yes, 0 stars and 1 galaxy. Then define these plot options, and the hover tool is a very fancy tool from my perspective that I'm going to show you what it's about. To use it, you have to refer what is the variable in the data frame that you want to hover on. So we define this figure that is not going to show anything because until you run this show bracket p, basically figure is an object that you can customize with different features from the for the plot. Circle is just a way to produce a scatter plot. So in bokeh, the scatter plot is not plt.scatterplot, but is circle. And here, running the and so you the mapping of the galaxy and stars was needed to having the legend here, and the hover just show when you hover on a point all the features that you were asking when you define the hover here. All these features will appear when you hover on a point. Here I'm hovering on 2 points, so it shows two sets of information. And then we can reproduce the plot, the color magnitude diagram that we saw in the previous. And when I hover on a point, the same point, the points in this case, the points I was hovering on are shown in the other two plots of the grid. Okay. Any questions? If not, I'm gonna run up another feature of the top. All the queries that we saw up to now are, let's say, synchronous query. Top service gives you two query mode. The synchronous one, that is the one that we used up to now, the feature of this kind of mode is that you have to wait for the job to finish before doing something else, because it is a job doing synchronously to your job, to your query. So this is we just are reproducing this query using the synchronous query. That is the one that we used up to now. And before running the following cell, we needed to wait, in this case, 11 seconds for these to query 1,300 objects. The asynchronous query does not need you to wait for the job to finish, because here we submitted the job to the service, and the query is just pending. So we can do every other job. We can run every other cell we need to run before the job, before to have the query. And here we run the job, and in this phase, we are just asking the job, give me the table of your query, and here we need to just wait a little bit more. And here we can see if the query ended without any error. After that, we can fetch our results. And as you can see, the two tables are identical, as the assert otherwise will have been raised an error. Okay. Here is what someone was asking at the end of the previous tutorial. So if I can retrieve the query from the portal, or if I can save the query from the portal, every query, as they are run from the portal or from your notebook aspect, have an URL as a reference. So this URL just took you to a page. Hopefully you can see this page. Is a black page, okay, where you can read all the feature of your query. So what is the person, the ID of the user that asked for the query, and your query itself. I'm sorry, I cannot. And again, if we go to the another thing that is interesting to see is that if we go to the portal aspect, we can just do the same queries, the same queries from the same query from the that we asked to the top. Here. So if you go to the portal and click on Edit ADQL, you can type your query here. let me just share this this query in chat so that you can reproduce it as we speak. And you can do here what Tina showed before, but you can do also oh, sorry, not here. Oh, sorry, I'm messing it up. Not here. Okay, here. If you type on the info button, you can also retrieve the URL you need to pass to the job in the notebook aspect to retrieve the same data. So if you copy permission denied. Oh, it worked before. I don't know what's going on. Apologies. Sorry, I tried this before and it worked. I don't know. But now it's this function retrieve query from my portal URL should give you the same query you did in the portal aspect, and then you can save your Panda data frame and use your tables as you want.
Fabio,
Yes.
maybe there is an extra D in so it's retrieved job instead of retrieve job.
Oh.
Yeah. Sorry.
No. Apparently no.
Apparently not.
Let's see, just no. Apparently it's not that. It is here in retrieve query, the problem. I don't know. I will check on that and share the result in on Slack. But believe me that I tried before and it worked. So that's all I have to show here with this notebook. I hope that everything was clear. If you have any question, please ask. I'll try to answer them in the most clear possible way I have.
Hi, Fabio.
was
So you
good,
did have a
thanks.
question on in the chat by Tanaza. They asked if you could show where to put the query again in the portal.
Oh, okay.
Mauricio answered
Sure.
too, but yeah, it might be good to just demonstrate that.
So, okay. When you go to the top search as the first aspect you see when you enter the portal, on the right, on top right of the page, there is this top service and view. If you click on the edit ADQL, it's gonna take you to this page that is basically the same page, but with a different visualization mode. But you can see all the schema on the left, and the query you can do on the right. And here there is also some helper. Then once you insert the query in this window, you can click on the search button and the bottom left, and it gives you the search results.
Cool. Thanks, Fabio. And then there's a couple more questions. But I don't know, Jeff, should we take our break, or is it okay for Fabio to address these two questions?
For me, so it's okay. Maybe we can have a break later, and then we just go into the collaboration part of the of today. That I think it's just the introduction of everyone.
Okay. Yeah. So Fabio, the quick question I think from Aki in the Zoom chat is, what would be the most convenient way to save the result to a FITS file?
Where is the most convenient way? Oh, of course you can use the AstroPy .io from import fits, and these, if I don't remember, yeah, okay, and you can use this package to save as a fits file. Fits dot if tab help me.
You may also be able to skip that import because remember the result tables, you can convert
that's
to an
true.
AstroPy table right away. So then once you do that, I think then you can just do dot save and it'll, or dot write, and it'll give you that option. There you go.
Here, yeah. Thanks, Jeff.
I think it might be right. Dot write.
Dot write.
With a W, sorry.
Right.
Maybe not.
Don't know. Anyway, maybe because this is a pandas data frame now.
You could always do convert to table and then.
Yeah. Oh no, maybe there was 2p code. Sorry. So it apparently does not.
Maybe not. What are the results? Is it results? Is it, what is results? What format is that?
Is a
it might be a
results is this one, so it's a pandas, but we can also do that and just have the table. And then from here, let's wait a little bit. No, just the pandas, but right, maybe. Okay, right.
And then I think you just specify the file name.
Let's say test dot bits. No.
Oh, I was wrong.
Illegal format object. Oh, weird.
I mean, it's not too hard. It's just that we're kind of flailing a little bit. It's don't do it too often. But yeah, it's not too hard. We can look that up.
Yeah, we can. Yeah, we can look that up. Maybe the most basic way is to just import the fits package from astropy.io and save it as a fits in that way. Oh, I was able to respond that.
Yeah, sounds good. Thanks, Fabio. I think, yeah, hopefully that addresses that question. I mean, I would think you just use your, whatever your standard or your favorite way to convert table to fits file and do it that way.
Yes. And if you
Okay.
have any other question, you can text me on Slack and I'll try to answer.
Yep, there's a couple more questions for you on the Zoom chat, so maybe you can take that either
Oh.
during the break or the next session.
Okay.
Yeah, thanks so much, Fabio. That was fantastic. Since we're a little behind, hopefully people are okay with if we take just a 5-minute break and then, well, actually today. Yeah, okay, let's do a 5-minute break. And then when we come back, we will spend a little bit of time getting to know each other, and then keep in the back of your mind, think of sort of explorations that you might be interested in as the week goes on, so that we can brainstorm a list of ideas of projects that people want to work on together. It doesn't have to be a big elaborate project. It can just be something simple like, I want to make a color diagram that and see where galaxies and stars live in that diagram or something. But just think of ideas, any idea. None are too simple, none are too complex, and we're going to use those as ideas for things to work together on as the week goes on. So for now, let's take a few minutes break. What if we return? It's 12 after the hour. We return at 17 after, and then we shall resume. All right, break time. Hi, everyone. Sorry for shortening the break. We will we'll try and keep on time. We have a lot of material to cover this week, so hopefully we'll try and keep on time as much as possible. But now we're going to just do a very simple thing. It's kind of an experiment, so if we have technical issues, we'll work it out. We were going to divide people randomly into breakout rooms. I think I'll do 3 since that would be just over 20 people per room, and just introduce ourselves. If you made a slide in the shared slide deck of profile slides, you're free to speak to that slide, or if you want to just unmute and speak and say hi, just introduce yourself to everyone and what your interests are. That's great. And if you don't feel comfortable with either a slide or speaking up, you're welcome to not do either. So we'll just ask people to raise their hands if they want to introduce themselves. So we'll do that, and we'll divide into 3 rooms. We'll spend 15 minutes. People can introduce themselves, and then we'll ask you to go to a different breakout room, and we'll do the same. So you'll meet at least 2/3 of the people who are attending. And then after that, we're going to come back together in the main room and just do a brief sort of brainstorming list of sort of people can name explorations that they would like to dive into this week during the breakout times. So we can then you'll know people a little bit, so you'll know people who have similar interests to you, and then if somebody says, hey, I'm interested in looking at a light curve of a variable star, if that's your interest as well, maybe you can team up and work together in the breakouts as the week goes on. So hopefully that was a clear plan. So I'm going to just randomly assign everyone in in breakouts, and we'll make sure we have one of the organizing committee members in each breakout so that we can keep things going. And then we'll be there 15 minutes. And then I'll try and send a message to all the breakout rooms to remind you to switch to a different breakout. So, all right, here goes the experiment. Room 1, room 2, room 3. All right. I'm going to open them and we will quickly confirm that we have an organizing committee member in each room once I do that. So we might shift around for a minute. Okay. So you should be invited to join a breakout room. Let's see, I can't find the Tucson conference room one. Did I already get assigned to somewhere?
Yeah, I got assigned to Zoom room 1, but would you mind assigning us to room 2? Because I think our laptops are going to go there.
Oh, right. Okay. Move to room 2.
That's doable. Oh,
There you
okay.
go. And then let's see. And I'll go to, do we have anyone in 3?
Yeah, I guess we are all back in the main room now. But I thought we were going to get transferred automatically to some other breakout room. We should have gotten transferred automatically, but that has not.
Maybe we were too hasty in going back to the main room.
I suggest everyone rejoin the next room +1. If you're in room 3, you go to 1.
Okay.
Go to 1, go to 2, 2 go to 3. It doesn't rotate.
Okay, so we
It
were
is
in,
manually to do that.
yeah, but then we'll all end up in the going to the same room, right?
Oh, yeah. Okay,
We'll meet
that's
again.
true.
Yeah, we meet the same people again.
Oh, yeah, I got a point there. Flip a coin.
Yeah. I think we can ask people to randomly choose one of the other 2 rooms. I think that would work. At least we'll meet some new people.
Is Jeff in here?
I told them about anime and there is another anime fan now we are talking about anime.
Okay, very good. I can't even join any other room. It
Yeah,
says I've been
same
assigned
issue.
to room number 1. And
Exactly,
I'm
yes.
there. Yeah.
We are at the mercy of the organizers.
Yes. So we just have to wait here, I guess.
Okay.
Continue chatting.
Hi, everyone. Yeah, I'm trying to message Jeff right now to let him know. He should figure it out in a second.
Yeah, we'll just wait.
Yeah. Well, whoever didn't go before can go now. Douglas is back. I don't see where Jeff is. I just sent him a message on Slack. So
Okay.
Jeff is still still talking in our room, but he's
okay. Could you pop back in there and tell him that the experiment is not working and we cannot select a different room?
Yes.
Because I'm not allowed to go in that room unless he shows up real quick. So our experiment has failed, but that's okay, right?
It's just the first iteration. An experiment needs much more to fail.
Very true. Very true. We know this is not the way you do it. I think it was because he assigned them. If we had just been randomly selected, then that might have been different, but that's okay. I think everyone's coming back now. Hi, Jeff. You're muted.
The recording announcement just reminded me that I'm going to stop recording now. Breakout rooms aren't recorded anyway, so don't worry about that.